Hello friends, my name is Lokesh. In this session, we will be looking into how to calculate the elasticity of substitution for the Cobb-Douglas production function. So I will start with Cobb-Douglas production function. It is written as A K alpha L beta. Okay. Then we can see how we can derive the elasticity of substitution. It is written as sigma is equal to percentage change in K by L divided by capital output ratio whole divided by del MRTS LK divided by MRTS LK. So this is how we calculate elasticity of substitution. What does it means? It means what is ease with which we can change the capital output ratio per 1 unit change in marginal rate of technical substitution, that is with labor comma capital. Now here we will be calculating firstly what is MRTS LK. We know MRTS LK is calculated by del Q by del L divided by del Q by del K. Now we can derive del Q by del L by putting del by del L into Q. What is Q? It is A K alpha L raised to the power beta divided by del L by del K A K alpha L beta. Okay. Now we can just solve it. How we can solve it? We can solve it by pointing, differentiating it. Since it's a partial differentiation, so here A and K alpha will come outside. So A K alpha, and we will get beta L beta minus 1 divided by, it will be A L beta similarly, but since it is K and either K raised to power alpha, so it will come out alpha into K alpha minus 1. So if we solve a little bit, we can see that A and A can be cut out, beta and alpha are common, we can put it outside, beta comma alpha. Then we have K raised to power alpha L raised to power beta divided by L into K raised to power alpha L raised to power beta, and here again since there is a minus 1 it will come be here, so we will multiply outside, so it will cut like this. So we will end with K and L, so we can write beta by alpha into K comma L. So this is what it is, MRTS LK. Now we have got MRTS LK for Cobb-Douglas production function. Now it would be easy for us to solve for sigma. Now we can take log on both the side of this MRTS LK. So if we take log, what we write? Log of MRTS LK is equal to log of beta by alpha into K comma L. Now we can apply the property of log, which says if there is a log m into n, it can be written as log m plus log n, log m plus log n. So here this is m, this is n, so it can be written as log of beta by alpha plus log of K comma L, and here it will be same, we can write log of MRTS LK. Okay, now we can differentiate both the side with respect to, okay, so what we'll get, so how we can next property that we need to look into, the differentiation of log d upon dx of log x is firstly 1 upon x into dx by dx. Since here it is x, so there it is x, so it is like that. So this is a property. So whatever here it is, it comes to the denominator side. So if we differentiate on both the sides, what we'll get? We can get it is 1 upon MRTS LK into d MRTS LK is equal to, if we go for the right hand side, since it is a constant, so differentiation is 0, and for this word term we can get 1 upon K comma L into d of K comma L. Now since we have solved up to this, this is our LHS and this is our RHS. We can write it like this. Let me refine it. It is written as d of MRTSLK divided by MRTSLK is equal to d of K by L divided by K by L. I have done nothing but just I put this below this, and I put below this. Now I will take everything as a denominator on this side. So when it will go as a denominator, it will leave here 1, and what it will do here, it will leave d of K comma L divided by K comma L divided by, or you can write d and del, they are same, do not get confused with it. Or we can write d of MRTS LK divided by MRTS LK. Now we can see, if you see from the very starting, what we have written the elasticity of substitution is sigma, which was equal to percentage change in K by L divided by K by L divided by percentage change in MRTS LK divided by MRTS LK. What we have got here, we have got exactly the same thing, and this was what, sigma. So we have concluded here that sigma is equal to 1 for Cobb-Douglas production function. Cobb-Douglas okay. So we have got one very good identity, that for Cobb-Douglas production function, elasticity of substitution is 1, and we can remember this fact, and it is quite useful if you look into Indian Economic Services or UPSC economics optional. Okay, so I think you have liked my video. If you really liked it, then kindly like and subscribe the channel. Thank you.